Hi everyone, so today we have a question of chapter 2 inverse trigonometric functions exercise 2.2 question number 9. So the question is write the function in the simplest form tan inverse x upon root over a square minus x square where mod of x is strictly less than a. Okay, so we have to simplify this expression. So let us start with the solution. Okay, so here we can see that we are having, let us write down the question first, tan inverse x upon root over a square minus x square, root over a square minus x square. So here we know one thing, that if we have root over a square minus x square form, then there is a rule that you have to substitute x is equal to a sine theta. Okay, so let us put x is equal to a sine theta, right? So now this expression will become tan inverse x upon, because x is a sine theta, so now x will become a sine theta, so this is a sine theta upon root over a square as it is. At the place of x square, this will become a square sine square theta, right? Because x square, so x is a sine theta, so x square will become a square sine square theta, right? And now this we can write down as tan inverse a sine theta as it is. From the denominator, I can clearly take a square common first. So if I take a square common, what is left? 1 minus sine square theta, right? And now this will become tan inverse this a sine theta as it is, a sine theta upon, here we have now root over a square. Okay, now 1 minus sine square theta. So here we are going to use a trigonometric identity, and the identity is sine square theta plus cos square theta is 1. This is a very famous trigonometric identity. We all know this, that sine square theta plus cos square theta is 1. So from here, clearly cos square theta will become 1 minus sine square theta, right? So therefore, we can write down at the place of 1 minus sine square theta, cos square theta. So therefore, this will become cos square theta. Okay. This is cos square theta. Now this we can write down as tan inverse a sine theta as it is. And in the denominator, we are having a square cos square theta. So that a square cos square theta we can also write down as a cos theta whole square, right? Because we are having square on both the terms. So clearly we can write down that as a cos theta whole square. Now this will become tan inverse, again a sine theta as it is. In the denominator, we are having square root and square. So clearly both will get cancelled. So what we are getting? Just a cos theta. And now this a and a will get cancelled. So what we are getting? Tan inverse sine theta upon cos theta. We all know that sine theta upon cos theta is nothing but tan theta. So using this, clearly this will become tan theta, right? This is tan theta, tan inverse tan theta. Okay. Now there is another formula we are going to use, and the formula is, if we have tan inverse tan theta, so that will be equal to theta. Okay. That will be equal to theta when theta belongs to open interval minus pi by 2 to pi by 2, right? Now here we are given one condition. First of all, we are given a condition, as you can see in the question, that mod of x is strictly less than 1, less than a, right? So let us write down that first. So here we have mod of x is strictly less than a. What is the meaning of mod of x strictly less than a? Let us first understand about that. So if we have mod of x strictly less than a, then there is a formula that this x will lie between negative a to a. Okay, so this is a formula. Okay, now here we have x is equal to a sine theta, right? So if we have x is equal to a sine theta, so at the place of x I can write down now a sine theta, right? So now we can clearly see that this will become minus a sine theta, and then this is a. right? Now if I divide by a throughout, right? So what this will become? Minus a upon a, which is minus 1. This is a sine theta upon a, so only sine theta. And this is a upon a, which is 1. Now here we can see that we are having a sine theta, range for sine theta is minus 1 to 1. And this is nothing but theta belongs to minus pi by 2 to pi by 2. So since we are getting here that theta has a range from minus pi by 2 to pi by 2, and here we are getting in the formula, if theta belongs to minus pi by 2 to pi by 2, then we can write down tan inverse tan theta as theta. So therefore we can clearly write down here tan inverse tan theta as theta using this formula, because we are getting theta in the range, right? Now you can see here that we had taken x is equal to a sine theta, right? So since we had taken x is equal to, we had substituted x is equal to a sine theta. So from here we can also write down x upon a is equal to sine theta, right? Now if I take sine inverse on both sides, so what this will become? Sine inverse x upon a is equal to, because we have taken sine inverse on both sides, so this will become sine inverse sine theta, right? Now there is another formula. We know that if we have sine inverse sine theta, that will be equal to theta. So using this formula, clearly we can write down this sine inverse sine theta as theta, and here we have sine inverse x upon a, right? So what is the value of theta we are getting? The value of theta we are getting is sine inverse x upon a, and we have here theta, so theta will be what? Since we have theta here, so theta we got nothing but sine inverse x upon a, right? And this is nothing but the final answer. Okay, so let us write down the final answer. So this is our final answer. Okay, so that is the end of the solution. I hope this answered your question. Thank you so much.